So everything I'm saying right now is being recorded. We're going to look at how do we fill this handout out. How do we get from distance out of time? So let's look. Does everyone have the handout? No. All right, so Spencer's passing out the handout. As soon as you get it, look at part B. Go ahead and kind of skim through that. You're going to get a meter stick. And our meter sticks are what? What are the units on our meter stick?
Centimeters.
Centimeters and millimeters.
And 1 meter.
Inches is the other side. We don't use the inches. That's the English system. So this is part of why I'm actually trying to record this. Capture this here. So if you read over here, it says to make a timeline, we're going to use a scale. 1 meter equals 1 billion years. This represents 1 billion years for this scale. And that means every 10 centimeters, or I'm sorry, every 1 centimeter equals 10 million years.
Write that down.
Okay? And every 1 millimeter equals 1 million. Your unit conversions of centimeter to meter and millimeter to centimeter is the same. That hasn't changed. That's why we're doing it like this. Okay? Question?
What are they again?
So, as it's kind of hard to see. So, a meter represents 1 billion years. So, every meter stick represents 1 billion. Every 10 million years is equal to 1 centimeter. Now remember, a centimeter is 10 times greater than a millimeter. That means 1 millimeter equals 1 million years. Does everyone see this? All right, so I'll probably break this, and this would be like instructions, part 1. And I'm also going to do the regular video style. Let's start with the biggest one. So you guys are going to work on this after the quiz. You're going to do these conversions. We'll do like 2 here, and then you'll realize how to do the rest, and then we'll check your answers. So 4.6 billion years is equivalent in time to what? What?
4.6 million. 4.6 billion.
Okay, you're keep working on it. Okay, if 1 billion years is equal to a meter stick, so how many meters am I going to need? Wait, just start with that. If we're measuring out 4.6 billion years, we're saying every meter stick represents 1 billion years. So if I lay some tape down here and say this is the present, and I throw the stick down, that would be 1 meter would be 1 billion, 2 billion, 3 billion, and at 4 meters, am I going to go all the way to 5 meters? No. So somewhere I'm going to stop. 0.6 meters is the same as what? 60 centimeters. So I'm going to write this, but in parentheses, make a little mental note to yourself. So that is equivalent to 4.6 meters. When you actually measure it out, watch what I'm writing in parentheses. 4 meters plus 60 centimeters. Does that make sense? So let's say where I am in the board. So I've measured out, I'm at the 4 meter point. I throw my meter stick down, and I'm going to go all the way to 60 centimeters, and then draw a little line, and I'd measure that, 4.6, the beginning of Earth. It's actually about 4.5, but we're going to go ahead and say 4.6 because it says it on the handout. Well, we'll elaborate on how they came up with that calculation next class break. Does this make sense? So the goal, and we're going to talk about how we're going to use these numbers. So you guys are going to do your calculations, and then we're going to lay out some tape, some register tape, 5 meters long, and measure out everything on this handout is going to get transferred to the meters, to the tape. All right? Everything there is going to get transferred. So, what you guys are going to do is you're going to measure out 5 meters of this. And every meter you're going to mark off. You can wait if you want to. So they're still in the Dave. So. All right, so that's pretty much we got our. Every one of these is going to be measured out, and then all the ones on the handout, you're going to identify them on this paper. So we'll talk more about how you do this in a second. So I'm going to do this. I'm going to go ahead and just stop the video, and we need to do a couple other things.